right, let's look at the bell work. Did Reese do this correctly or incorrectly?
He did it wrong, got
Right answer.
Got the right answer. So where do you think he went awry? Yes, ma'am.
He did multiplication before he did exponents.
He did multiplication before he did exponents.
Because there's nothing going on inside the seeds. You can't
Yeah.
do anything with those separate.
However, when you get to this line right here, is that different than if he had done it according to order of operations precisely? Nope. Should have done the exponents first.
He got the answers.
But this is not wrong. I think it's important to look at work and see if a mistake has actually been made. They did something kind of out of order, which could have caused a mistake. And on other problems, it could have messed you up really bad. So it is important to identify that. In this particular case, Reese got off easy, and it didn't end up throwing off their work. So, did Reese actually finish the problem?
No.
No.
You had to simplify.
Should be what?
Negative.
-5 is what the final answer should be. So this is the final correct answer.
So he technically didn't get it right since we had simplified all the way.
So this is one that if I saw this on a test, I would give this full points. I would probably still circle that and say, be careful here, but on this particular problem, doing that multiplication before they did the exponents didn't actually mess them up. All right, let's look at the second one down. How do I tell whether we've shifted to the left or to the right at all? Where am I going to be looking for that?
For X and
Yes, look at the X's, look at the inputs.
see if they changed.
Did they change at all?
No.
No, these are the same.
So nothing happened.
So did it shift to the right?
No.
No.
And then shift to the left either.
We had no change here. What do I look at to see if it went up or down at all?
Your F of X and G of X.
F of X, G of X, the Y columns here. Did these change?
Yes.
+3. So if I see +3 all the way down here, I'm going to write that a little bit differently just so we can see it.
So that means it went up 3.
Then that means it went up 3. Yes. Because I'm comparing where it was to where it moved to. So we went up 3. What would it look like if we went down 3?
It'd be a negative. So it will go from 3 to negative 0.
Just 0. But yeah, you're right. It would go from 3 to 0. It would go from 4 to 1.
Oh, yeah.
It would go from 5 to 2. That's what it would look like if it was going down. So now I'm looking at these 3 equations at the bottom. We selected the correct transformation, up 3. Which one of these 3 transformations, D, E, or F, describes that we went up 3?
D.
D.
E makes it seem if that's the X, well, that would be the X inputs, and those going to change, and then G of X is correct.
Yes, G of X, this is saying down 3 right here on the bottom for choice F. Choice E, we didn't pick that one because we didn't go to the left or right at all. Which direction is E saying it
Left
went?
and right.
Which way though?
Oh, it's saying it went left.
Yes, this would be left 3 here. So A and D are the correct choices here. All right, I need you to flip forward in your books to page 164. We're going to talk about something called absolute value. Absolute value looks like 2 vertical bars around either a number or a variable or an expression. Looks like 2 vertical bars. And the definition for absolute value is the distance. Just find a spot somewhere on page 164 to write this down. It doesn't have room for a definition, but find an open spot. You guys have all that room at the bottom. I want you to write this down. The distance away from 0. Question for you guys about that. My family here in a couple weeks, fall break, we're going to go down to Tennessee for fall break. I'm super excited about this. We're going to be heading down to the south. Would I tell you guys that my family is planning on traveling negative 300 miles for fall break? Why not? You can't go negative miles. Distance is never negative. Make a big note of this. Distance.
Same with money.
Is never negative. Good question. So absolute value is always going to be a positive number. You guys have this same table in your book, although I've been told that the last 3 numbers on your page is different than mine, right?
4 and 6.
Okay, so I want to know if I'm standing over here at negative 6 on the number line. Absolute value is describing how far away we are from 0.
Positive 6.
How many hops is it going to take for me to get to 0? 6 hops, so the absolute value is 6. What about if I was standing at negative 4? 4. If I was standing at negative 1? What about if I was standing right at 0? 0. Like if somebody called and said, hey, how far away are you? And you're like, I'm here. No. How many miles? 0 miles. Let's do the one on my table, and then we'll do the one in your book. So for the next 3, 2 units away from 0. 3 and 5. Fill in your book with the correct distances there.
So,
1, 4, and 6. Yes. Okay, there's a couple other things that I want you guys to get written down in that blank space. First one, I want you to write down the absolute value of 10. So 2 big bars around a 10. We're going to write down the absolute value of negative 10. And then I want you to write down the absolute value of x equals 10.
so wouldn't that be negative 10?
Absolute value is the distance away from 0. So if I'm standing at 10 on the number line, how many hops would it take me to get to 0? 10 hops. If I was standing at negative 10 on the number line, how many hops to get to 0? 10. For this one down here, the 10 over here is my distance. The x is the location. Absolutely correct. We could be at negative 10 or positive 10. If all I tell you is how far away from 0 I am, then I could be on either the left or the right side. And so I have to give both possible locations. So x would be equal to 10 or negative 10. X is my location. What comes after the absolute value is my distance. Right, there's one more thing that I want you guys to get written on this page in that empty space. I want you to write down the absolute value of z. So 2 big bars, absolute value of z equals -5. What is this saying?
That you end up on the left side of it.
Remember, this inside here is my location. The other one is my distance. If it's not inside the bar, that's how far I am from 0. What'd you say, dear? Can my distance be negative? Distance can't be negative. If I'm looking for the location, the distance has to be a positive number. So this one over here, if you see absolute value of something equals a negative, that's not possible. Why is it not possible?
Because you can't go negative on the distance.
You can't go a negative distance. Distance is never negative.
Is this what homework's over?
We are going to practice doing some graphing today with absolute value. I'm going to have you flip forward several pages. We're going to go to page 175. Page 175. We're going to start off with just some transformations. Do you guys remember AH and K? AH and K do the same things, whether we're talking about quadratics, or tables that I don't know an equation for, or graphs that I don't know an equation for, or absolute values, or any number of different kinds of transformations that we'll look at this semester and next. So here is my transformation form, my vertex form. Tells me where to look for AH and K. So looking at number 1, which piece of the transformation, AH or K, is this 1/2? That is A. If A is a decimal or a fraction, what's it going to do to my graph?
Oh no, it's compressed.
It's going to compress it. What would reflect it?
Negative.
Negatives. So we would say vertically compressed.
Or no, will we?
Yep, by 1/2. Then I move over here.
That's your A can go by 1.
Yes. I see the opposite of H right here, and so that means that H is actually a positive 1, and so you're absolutely correct, Lauren. That means that we go to the right one. And then who is that on the end?
Okay.
That's our K value. And Soraya, you said it's going which way? Up 3.
Vertex would be 1, 3.
That's absolutely correct. Just like with the last function, my vertex is HK, and so that is going to be 1, 3. I want you guys to take right about a minute to do number 2. Identify your AH and K, identify your vertex, and then write down in words how this is going to be different from the parent. So where is the vertex for number 2? -8, -10. Very good. Going to reflect over the x-axis. Who's doing that? The -2, our a value.
It's gonna vertically stretch by 2.
That's absolutely correct. This will reflect over the x-axis. That's what the negative part of it's doing to it.
Can you take away the negative? Just look at the number.
Yes, then you take away the negative, you just look at the number, and that will vertically stretch it by 2. How else is this going to move?
Left 8, yes.
Left 8 and down 10. Good job. Left 8 and K is going to send it down 10. Okay. Do you guys feel all right with describing these transformations and identifying our AH and K?
Yep.
Let's practice graphing. The biggest thing that's going to be a change for us is just what the parent looks like. So let's practice that part first. Down at number 3 on the bottom of the page, we're going to graph our parent function first. The parent function is the absolute value of x. So I'm going to come down here to these 2 tables. I'm going to join them together. I'm going to put my x's on the left and my y's on the right. When I'm talking about distance away from 0, if I told you where I was standing on the number line, could you tell me how far I was from 0?
Yeah.
Could you do that no matter where I was standing on the number line?
Yeah.
Yes. That means we can pick anything we want to for x.
Because wouldn't it be the positive number of that?
That's absolutely correct. Which means if it's already positive, you just repeat back to me. If I tell you I'm standing at a negative place on the number line, you just take away the negative. And that's how far away I am from 0. So for my parent function, because we can pick anything we want to for x,
-2, 1, 0, and 1 and 2.
yes. My domain is all real numbers, negative infinity to positive infinity. And I like to pick my 5 favorites because they're easy for us to work with. -2, -1, 0, 1, and 2. Close. 4, 1, 0, 1, 4 was when we were taking things and squaring them, because that was for a quadratic. Now I want to know what is the absolute value. How far are these numbers from 0?
So 2, 1, 0, 1, 2.
Yes. -2 is 2 units away from 0. -1 is 1 unit away from 0. 0 is 0 units away from 0. And then 1 and 2. How far away are those numbers from 0? So I'm going to go and plot those points. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Do you guys remember how the parabolas, I said don't pull out your straight edge because it makes a U shape and it's curved?
Yes.
These do not make a U shape.
Make a V.
These make a V shape. You might want to pull out your straight edge for these. These make a very strong V shape. We still describe that point that's at the bottom as the vertex. On this parent function, is that vertex right here a maximum or a minimum? Is it a highest point or a lowest point? Lowest, so this is a minimum.
So this is the lowest it's going to go.
Lowest it's ever going to go for the parent. Speaking of the lowest it's ever going to go, when I'm talking about the range, I'm looking up and down. What is that lowest point on the parent?
0.
0. What's the highest point on the parent?
Infinity.
Infinity. We have arrows on the end, so it keeps going forever.
But we don't put brackets around that. 'Cause they're
Correct.
absolute.
That's absolutely correct. So that's what our parent function looks like. Very similar to a parabola, except not a U shape, it's a V shape. My x's stayed the same as a quadratic, but my y's are talking about how far they are from 0, so those are different for this one.
We still do the like jack thing over times. I mean, adding.
Yes. We're still going to deal with our transformations in the exact same way. So I need to know what those transformations are. What's our A, H, and K? A is 2. H is positive 5. And K is 1. So what will that do to my graph? How would I describe it in words?
Vertically stretched by 2, right 5.
No, left by 5. Or no.
No, it's
Oh, I was looking direct.
Yep, it is right by 5. Anything else?
Oh, it goes up 1.
Up 1. So vertically stretched by 2, right 5, and up 1. Which of those transformations is going to affect things along the x-axis?
the right.
The right 5. So I'm going to take that h value, and on my table, I want to see it doing to my numbers what we said in words. If I was standing at -2 on the number line, and I took 5 hops to the right,
You get positive 3.
we would end up at positive 3. If I was standing at -1 on the number line and I took 5 hops to the right,
4.
4,
And it's 5.
and then it's going to be 5,
6, 7.
and 6, and 7.
But then you
Now
have to
you multiply
multiply.
the y by 2.
We are going to multiply the y by our a value. Anytime we're stretching something, it's going to be multiplying. Anytime we're shifting up or down, that'll be adding or subtracting. According to order of operations, do you do multiplying first or adding and subtracting first? Multiplication. So that's why we need to multiply by our a value first before we shift up 1.
So 4, 2, 0.
Yeah. Don't forget, though, we're going to take them after we multiply and then make them all go up 1. So for my new y's,
The first one is 5.
5, because 2 times 2 is 4, plus 1 gives me 5. And then 3,
1.
1,
3.
3.
Oh, it repeats.
It repeats, just like with our parabolas, because it does come back up on the other side. Let's go plot these points now. 3, 5, so right here. 4, 3, 5, 1, 6, 3, and 7, 5. Do you guys see that V shape taking place there? Yes. Grab your straight edge and draw through those points for me. This vertex here at the bottom, is that a maximum or is that a minimum? Minimum. And then it keeps going from there. Thank you. I need to talk about the domain and the range for the transformed function.
It's still negative infinity and comma infinity.
For our domain, yes. If we can pick anything we want to for the x's for the parent, we can pick anything we want to for the x's on the transformation. Range, I still want to start with the lowest it ever goes and end with the highest. I don't care about the left and right part at all when I'm looking at the range. You said we have a minimum here, right?
It's 1.
1. The lowest it ever goes is 1 with a bracket around it. What's the highest it ever goes? Infinity, because we have the arrows on the ends. Before we go practice with one more graph, there's something else I want to draw your attention to, because it's easier to see with these graphs than it was on the quadratics. Look at the blue one, the parent one. Do you see that vertical distance between these points? How it was 1 unit up? Look at this transformation. How far is it between the points now? 2 units. We said this was a vertical stretch of 2. That's what that looks like on my graph. We've stretched these apart by 2 now instead of just by 1. Let's practice graphing one more of these. So go ahead and turn the page. We're going to look at number 4, and that's where we're going to shut it down for today after we're done with that one.
It's gonna vertically stretch by 2, and it's gonna compress. No, it's gonna reflect, sorry.
It's going to reflect. Let's get our parent on first, and then we'll go do our transformation. So my parent function, f of x equals the absolute value of x. So I'm going to come down here to my table. I'm going to put the x's on the left and the y's on the right. Do we get to pick our x's for the parent?
Yes.
Yes. What kinds of x's can we choose?
And positive.
I can choose negatives. I can choose positives. So how would I describe my domain then?
Infinity and positive infinity.
Negative infinity to positive infinity. What x's do I want to pick for this graph? -2, -1, 0, 1, and 2. And there's nothing magical about those numbers. They're just easy to work with.
So 2, 1, 0, 1, and 2.
Yes. Over here on the y side, how far are those away from 0? So the distance from 0. 2, 1, 0, 1, and 2. What's this going to look like when I graph it?
A V.
A V. Let's go plot those points. -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Use your straight edge to get a nice sharp V shape. Quadratics, we don't want to see a U shape. Quadratics, we don't want to see a V shape, so don't use your straight edge, but on absolute value, we do. I always keep that straight in my head because absolute value starts with V, and I'm going to make a V shape. Down here, this point right here, that is a minimum, right? So what is the lowest the parent function ever goes? 0 and then to positive infinity. All right, now let's go look at that transformation. We'll talk about A, H, and K. What is our A value? -2, right after the equal sign. What will that do to my graph? Yes, it's going to reflect it first and then stretch afterwards. So reflect over the x-axis,
Something's going to be negative.
and it will vertically stretch it by 2. You said h is left 1, so what number would we use for h? -1. And what about our k? Down 3. So what number are we using for k? -3.
So that's what it's going to make it go down.
That's what's going to make it go down after we stretch it. Which of those pieces affect things in the x direction along the x-axis? H. We said we're going to the left 3, to the left 1, my apologies. So if I'm standing at -2 on the number line, and I take 1 step to the left, now I'm at -3. -2 next, because if I'm standing at -1 and then I go to the left 1, that would put me at -2. And then -1, and then 0, and then where? 1. If when we make these tables, this part of it right here isn't making sense to you, look at the words. We want it to do what we said in words. So think about where you are on the number line, and then think about where you would end up if you did this transformation. And you can write those down. Then we go over, we need to find our new y's so that we can get those graphed. Yep. We're going to multiply by a first so that we get our stretch and our reflection right there. Multiply everybody by -2 first. And then what else will happen to the y's? Plus -3, yes. Plus -3 is the same thing as subtracting 3.
So you can
-7, because 2 times -2 is -4, right? So I'm at -4, and then I go down 3 more. So -7. What is 1 times -2? -2, and then I'm going to go down 3 more. -5. 0 times -2? 0, but then I go down 3 more. -3. And then what happens after that? It's going to repeat. That one right in the middle is my vertex, and then I'm going to see it repeat from there. These are the points we're going to go and graph now. -3, -7. -2, -5. -1, -3. 0, -5. And 1, -7. You should see a V shape, but what's different about this V shape? It's upside down. It is reflected. That's absolutely correct. So this vertex right here, is that a maximum or a minimum? It's up at the top, so it is now a maximum. Last thing we need to do is domain and range for our transformed function. What are we allowed to choose for x?
so infinity.
Yes, anything we want to. So -infinity to +infinity.
And then it's negative infinity.
Yes, -infinity, because it doesn't have a lowest, it points down, but then we want to end with the highest. What's the highest this graph ever goes? -3. The highest it ever goes is -3. All right. That wraps up today's lesson. In case you guys forgot, you did have homework due this morning that you were supposed to do over the weekend. If you forgot, get it done tonight. It's not horribly long. I think it's like 6 questions long. Not horribly long. There is a homework due tomorrow as well, over graphing stuff. Please make sure you complete that for tomorrow. This is a very fast-paced unit. Our next test is next Thursday, day before we are on fall break.